All right, so in population ecology part 2, we're going to talk a lot about population growth and things that can affect population growth. But at its very basics level, population growth is defined by the number of births minus the number of deaths. More births than deaths, population is going to increase, positive growth. More deaths than births, you're going to have negative growth, the population is going to decrease. Now, for some population migration, immigration can increase it and immigration can decrease population size, but that doesn't affect all populations equally. So under ideal conditions, you have the exponential growth model going on. And here's our formula. N is the number of individuals in the population at the start. R is the growth rate. Ri is intrinsic growth rate, which is the maximal growth rate you can have in that environment. T is time, and D is the rate of change. Okay. So the higher the intrinsic growth rate, the faster it's going to grow. So exponential growth occurs when populations don't have any limiting factors. There's enough of everything to go around. So for any length of time, that's not going to be the case. But whenever you have an introduced species in a new environment, oftentimes you see this, or rebounding from some type of catastrophe, like when they started protecting elephants from poachers and hunters, the population grew pretty quickly. Same thing with whooping cranes as they came back from extinction. So, like I said, under ideal conditions, you get exponential growth. But most of the time, we don't have ideal conditions. Instead, we have limiting factors that limit how large the population can be. Now, there's two kinds. There's density dependent. These are things that have a higher impact when the population density is high. So competition for food, for mates, for nesting sites, much more intense when there's lots of individuals in that area. Predators, parasites, and pathogens also affect population density, populations at a higher density, excuse me. Density independent are mostly abiotic factors. So things like sunlight, temperature, rainfall, they're going to affect the populations regardless of how dense they are. Also, natural disasters would be part of density independent limiting factors. Introduced species have caused lots and lots of havoc. Sometimes they've been introduced intentionally, but more often than not, it's been unintentional introduction by human activity. So these are non-native species, species that don't normally live there, that came from somewhere else. Because they don't normally live there, they don't experience a lot of the controls that the native populations do. They don't typically have predators that eat them. They don't have other things that can limit their size. They often outcompete the native species, and they cause all kinds of problems because of a loss of natural control, because there aren't predators or parasites or other competitors that can control their population size. It leads to a reduction in diversity, which is a less healthy environment, less healthy ecosystem. So Africanized honeybees, sometimes called killer bees, were first accidentally released in South America and have moved, as you can see on the map. Gypsy moths eat lots and lots of vegetation. Zebra mussels, we'll talk about those in a minute. The kudzu you can see there was intentionally planted along waterways in the southeast to control erosion, but it's quickly grown out of control and reduced the diversity. Loosestrife is another plant that was introduced that has kind of gotten out of control. So zebra mussels were accidentally released from a cargo ship ballast tank, which they're not supposed to empty those, but they did in the Great Lakes, and you can see how they kind of spread through much of the central and eastern United States waterways. They can clog up water intakes. They cause a reduction in diversity. They kill off the native mussels, which means there's less food for other things to eat. Economic damage can result in all kinds of things. Loosestrife, you can see in a short period of time, kind of took over all the native species in along this waterway here. So when there are limiting factors, instead of having exponential growth, as the blue line shows, if that's under ideal conditions, they're not going to have those ideal conditions forever. So instead, we see logistic growth, where as populations reach the maximum number of individuals of that species that environment can support, population growth is going to slow down. So exponential growth, no natural control. Logistic growth is the effect of natural control. So what we've added to this equation here is K. So 1500 is K for this species. So you could replace 1500 with K and get the formula for logistic growth. And you can see we've added to that exponential growth formula, accounting for the carrying capacity. So whenever populations get near that carrying capacity, growth typically slows, and you get a point where there's little growth from year to year. There may be slight variations, but not much. So the carrying capacity is the size that environment can support with no degradation of the habitat. Now sometimes things overshoot the carrying capacity, and that usually leads to a big crash in population because they overgraze or whatever, and they degrade the habitat in some way. So with the plankton, the environment is changing from year to year, so the carrying capacity fluctuates a little bit from year to year. Predator-prey cycles, predator-prey, herbivore, and plant interactions, you see similar patterns or cycles. When the prey goes up, the predators go up. As the predators go up, the number of prey go down, and we see this cycle repeating over and over. So it makes it harder to determine what the actual carrying capacity is, but in this case, these are in thousands. The snowshoe hare is about 45,000 in that particular environment. And the lynx, the predator population, is typically around just a little under 3,000 lynx in that environment. Human population growth is another story. We, because of technology, have changed our growth, our carrying capacity. So you can see early on in human history, there was little growth. And then as agriculture and we moved into cities and things got a little bit easier, our population started to grow a little bit more rapidly. Then we have this dip here with the bubonic plague, the Black Death. And then you see the Industrial Revolution, medicine, technology, clean water. All of those things have led to where our population growth curve is almost vertical at this point. So in 1650, there were 500 million people on Earth. In 2005, we've gone up to 6 billion. And that's a fairly short period of time. In 2005, we were adding about 82 million people per year and about 200,000 per day, and those numbers have gone up. That's just the latest numbers I had. So is the human population reaching carrying capacity? Well, we don't really know. Can we continue to raise that carrying capacity for a while? Maybe. With better healthcare, we can build skyscrapers so more people can live in the same area and all of those things that we've done. But the concern is we're growing so rapidly that we will overshoot that carrying capacity, and that will be followed by a big population crash, which we've seen in other natural populations when they overshoot the population, the carrying capacity for that population. Two real important populations to look at are China and India. China has 1.3 billion people, India about 1.1 billion people of that about 6 billion that were around in 2005. So those two countries accounted for over a third of all the people on Earth. So what you want to look at is the doubling time. How long did it take to go from 250 million to 500 million, from 500 million to a billion, from a billion to 2 billion? Again, start getting to recent history where it's been growing pretty quickly. Doubling time was about 80 years, 2 to 4 billion, about 75 years. So you can see that doubling time is getting shorter. That tells us we are growing very rapidly. So one of the things that we need to look at when we look at human population growth is where is the growth occurring? It's not really occurring in the developed countries. In fact, the developed countries are probably going to start to see a drop in population. It's in those developing countries. And so we have to look at, worst case scenario, if we don't do anything to slow population growth, this is where we're headed. We can reduce this by education and improving poverty, basically. There's an uneven distribution of population. 90% of the births today are in developing countries. So again, what is the actual K for humans? We don't really know. There's also an uneven distribution of resources. The wealthiest 20% consume 90% of the resources, which is increasing the gap between rich and poor countries. And again, this is just another way we can look at what could happen. So we have choices as a world we can make. The major thing that's going to affect those where we end up is income and education. If we can improve income and education in those developing countries, we can slow and decrease population growth to the point where it's sustainable. The other thing we want to look at is resource use. The United States per person has the largest ecological footprint of any country in the world, which is the amount of land required to support an individual at a standard of living of a population. We're more than double Germany, and again, start getting to the developing countries, and we are so far above how many acres of land it takes to support a person. Now, in the United States, we have the luxury of lots of land, whereas in a lot of countries they don't. So 86% consumption of resources and 53% of all the CO2 emissions come from the 20% of the wealthiest countries in the world. So do we have an overpopulation problem, an overconsumption problem, or both? How does this fit? So here we have above the line, these are countries that are in deficit. They're using more resources than they can produce. Whereas these countries here, which include some developed countries, have a surplus. So we have the ability to live with a smaller footprint. It's whether we have the will.